Oh, cool.
The other thing, feel free to keep yourselves unmuted if you just want to jump in, unless you have a bunch of background noise, then that can be a problem. But yeah.
All right, so I guess we'll just start with question 11 on drawing and adding vectors graphically on the review. So it says a pupper walks 56 meters to the left and then 60 meters to the right. Draw the vectors and then add the resolute. Include your scale. All right, so
Okay, we're starting on 11.
we're starting on 11, yes.
Let me just get there real quick.
All right, we'll wait. All right, so your scale can be, we'll have it as, all right, we'll have a 1 meter to 4 centimeter scale. So that's that. See that? Yeah. 1 meter to 4 centimeter scale. That's going to be our scale. So you're going to take your ruler. This is a simple vector. So you're going to measure out 56 meters to the left. So 56 divided by 4 is going to be 14. So you're going to draw 14 centimeters to the left, which is about from there to there.
14 centimeters.
14 centimeters because our scale is 1 to 4. So
wait, can you also explain like why the scale part, like why do you put 4, or like why, like you know how like in some equations she puts like 1 centimeter equals 1 meter. So how do you get to 4? Like what's like the reasoning behind it?
All right, so for scale, you don't even have to have a scale for this problem, but she wants you to include your scale. So a scale is like, you can't draw 56 meters. You don't have a big enough paper for that. So she wants you to like dim it down. So in order to dim it down, you need to have a scale. So if it's like if you're drawing like 3 meters, you can say your scale is for every 1 meter equals 1 centimeter, which is kind of like, have you seen a map, right? Where like it says 2 inches equal 500,000 miles.
Well, could every single person's scale be different, or like is she expecting us to have like somewhere around the same scale?
Your scale can be totally different. Your scale could be 8 centimeters to 1 meter, or it could be 5 centimeters. Everyone's scale is different. I picked 4 centimeters because 4 is easily divided by 56 and 60.
I got you. Okay,
that's why I picked 4. All right. So what you're gonna start off is, see if anyone's in. You're gonna start off going 56 meters to the left, so 14 centimeters. So this is 14. I measured this out with my trusty dandy calculator. So she wants us to go 56 meters and then 60 meters to the right. So we start here and then we come over here on the left. So we go 60 meters to the right. So we're going to measure out whatever 60 divided by 4 is, which is 15 centimeters. So we're going to start at that point. 15 centimeters is about right there. So we'll draw it going that way. And what the resolute vector is basically how far away your beginning to your end is. That's what your resolute vector is. So if I started here.
Andrew?
Yeah?
So.
I'm gonna mute Vic real quick. So if we started right here on this line and we ended right here, that's 1 centimeter. That's your resolute vector is going to be 1 centimeter, or if you want to like get down to business,
1 centimeter east or something? Do you guys use cardinal directions?
1 second.
I think
I messed up on my scale. I meant to say 4 meters equals 1 centimeter.
Yeah.
Yeah, that's why. That would have been. Yeah, okay, so 4 meters is 1 centimeter. So for every centimeter I go, it's 4 meters. So this 14 centimeters right here is 56 meters going to the left. And this 15 centimeters from here to here is 60 meters going back to the right. So your resolute vector is going to be this 1 centimeter, which is basically 1 meter. So you would put that, your resolute vector is 1 meter.
4 meters,
to the right. 4 meters to the
4
right.
meters. Yeah, I was about to say.
Sorry. I'm tripping up right now.
It's all
So that's
good.
how you do number 1. Well, that's how you do. A is basically drawing this out, and then B is your resolute displacement is basically the same as your resolute vector. You would put 4 meters
4 meters to the
right.
right.
Do you guys use like cardinal directions, like north, south, west, east, or do you guys just say left or right? Up,
we
down?
use that if it's for if we're doing it graphically.
Got it.
Oh, I got you.
So that's how you do number 1.
All right.
Let's erase this. Bloop, 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 bloop. That was one of the easier questions. All right, so the second, number 12, we're going on 12, if you just joined in, is a boat is traveling 25 meters per second west. So let's label it out. That's what you want to do first. Never eat soggy waffles. So you have that. And we'll have this as like your start. It goes 25 meters per second west and then 5 meters per second south. So I don't really need a scale for this. I can like eyeball it a little bit. So I start my origin. I go 25 meters to the west per second. That's how many meters. So I got 25 ms right here. Then I go south at 5, which is like that. So it's asking draw the vectors on the resolute. So I got to find the origin to the end. In order to do that, I can use a squared plus b squared equals c squared since I'm trying to find my hypotenuse, which is this. I'm trying to find this, so I got to use a squared plus b squared equals c squared. So we put 25 squared plus 5 squared, and that gives you 650. Then you have to find the square root of 650, which is 25.5, really, rounded. So your resolute vector, resolute displacement, whatever it is, your resolute is going to be 25.5 meters per second going. All right, so now you got 25.5 meters per second. That's your hypotenuse. And then it asks, now you're looking for the magnitude and direction. So what you're going to do now is, we can delete this. So you got west and you got south. We're trying to find the angle now. The angle it's going at. So first it goes south and then goes west. So in order to find that, we're going to have to use Sohcahtoa to find the angle of what it's going at. So we're looking for this angle. So we have the adjacent and we have the opposite. So we're going to use TOA. And so into your calculator, you're going to put second tan, then opposite, which is 5 over 25. So second tan, in the parentheses, you put 5 divided by 25, and you close parentheses, and you enter, and it gives you 11.3 degrees. So your boat is traveling 25. It's traveling, give me a second. 25.5 meters per second south, 25.5 meters per second at 11.3 degrees south. This is a little confusing. South of east. West.
So wait, what's the degree? It's 11.3 degrees?
That's 11.3 degrees.
So then that would be south of west, I think.
Yeah, south of west.
Yeah.
If you you put south of west because you have this, right? Never eat soggy waffles. And you start here and you go down. South of west means you're going this way, where west of south means you're going that way. So there's a big difference in putting south of west or west of south. And you can't just put southwest because it's like undetermined. You have to put either south of what, blank of blank, or blank of blank. Do we have any questions on that problem? Please speak up and let me hear your feedback. Anybody?
I have one question.
Yes, Alan.
How'd you know it was 5 over 25, not 25 over 5?
All right. Let me draw it out again. Loop. All right. what was it? This was 5. This is 25. All right, so we're looking for this angle right here, right, Alan? We're looking for this angle. And this angle, the opposite side is this. So this is going to be opposite, and this is going to be the adjacent, since this is right next to it. Now I can't draw. And this will be the hypotenuse, because that's always the hypotenuse. Now, if I'm using the opposite and adjacent, I'll be using TOA, right? You understand why I'm using TOA?
Yeah.
All right. Now, in TOA, you put, T stands for tan, the O stands for opposite, the A stands for adjacent. Whichever one is first, it goes on top. So it's like putting like a little like line through there. So the opposite is 5, and the adjacent is 25, and you'll put that into your calculator. Like that.
Actually makes a lot more sense.
Whichever one is first, like in so, you would put the opposite first, then the hypotenuse. In ka, you would put the adjacent first, then the hypotenuse, like this. You guys understand that? Alan, does that answer your question?
Yeah, thank you, Andrew.
All right. Anyone else have a question? Really, this physics test is just going to be heavily geometry based. So, yeah. All right. Okay. Number 13. Anyone have any questions on pages 1 or 2 of the review? Nobody? Okay. Number 13, it says, given the vectors below, vector 1 and vector 2, I have to draw the vectors and then find the resolute vector. All right. So if you have a protractor, this is a lot easier. Or if you have the website, that's a lot easier too. So we're going to give myself a little line. Never eat soggy waffles. And then, okay, so my first vector is going 1,500 meters second squared northwest, 30 degrees from the vertical. All right? All right, this is a little tricky, actually. All right, so this is the horizontal, and this is the horizontal, and this is the vertical. Yeah? So if it says I'm going northwest, 30 degrees from the vertical, that means I'm going this way. Like, I'm basically going north of west, 30 degrees. So 30 degrees right here is about right there. But first I need to get my scale. So 1,500 meters per second squared. I'm going to give a scale of, we'll go 400 meters per second squared equals 1 centimeter. Let's give 400. 100 meters per second squared, 1 centimeter. Okay, handwriting's off. So if you have a protractor, you can figure out the 30 degrees easily. I don't have a protractor, and so I will be going 3.75 centimeters that way. So gotta get you out your little ruler and your protractor, and then draw. So that's about 30. That's right about like right there. 30 degrees right there. So this is going 1,500 meters per second squared northwest, 30 degrees from the vertical. And then my second vector is going 400 meters per second squared, 25 degrees east of south. So I'm going to start again right here. Now I have to go east of south, 25 degrees, a total of 1 centimeter. So that's east of south. So it's about going like this. That's right around like that. That's a little ugly. Kind of like that, basically. So I'm kind of at the vertical, and then this is a lot easier. This isn't completely accurate. A lot easier if you have a protractor. Please get a protractor for the test. And then from here to here, I just measure out how far away it is, which is about 3.5 centimeters. So 3.5 centimeters times 400 meters per second, because that's my scale squared. You put that in, 3.5 times 400 it's 1,400 meters per second squared away from the origin. So your resolute vector is going to be 1,400 meters per second squared. And then you put the direction as whatever you get on your protractor going wherever your exit was. It's a little hard to explain on a whiteboard, really. I really have to like show you up personally, so this is a little harder.
Do you guys have to know how to like do it mathematically, or can you just like measure it out and then give your answer?
She wants us to. She says do it graphically, which means like we have to draw it out and all that.
Got it.
A lot of these times you can just figure it out on yourself. Like for this question, never mind. But like she wants us to solve it out graphically.
I see.
And sometimes we don't have to do that. That was a little hard question to explain. Sorry if I didn't explain it thoroughly. If you didn't understand, I'm really sorry. All right. We'll do this last question, then okay. Number 14, one of the last question. It says a floof travels along the ground. First they go 7 blocks west. Next they travel 5 blocks east. Then they travel 3 blocks north. Finally, they travel 3 blocks west. So, let me check the more chat. All right, so I'm going to draw it out real quick. So, he goes 7 blocks west. So, you got to label it out. Never eat soggy. No one told me that. Soggy waffle. So, he goes 7 blocks west. So, this is west, so he goes about 7 blocks. We'll say 7. Next, he travels 5 blocks east. Okay, so he goes back to the east 5 blocks. And then they travel 3 blocks north. So it goes up 3. And then they travel 3 blocks west. So that's about 3. All right. So first we got to figure out like the total amount of distance he's traveled. So we already know he went 3 blocks north already. We know that. Now we need to find out how many total blocks he figured out going west. So first he traveled 7, then he went back 5. So this is 2. So he traveled a total of 5 blocks west. You guys understand how I got that, or am I going too fast for that?
Going too fast. Can you like?
All right. I'm sorry. I went too fast. All right. So now let me just bloop. All right, so he goes 7 blocks west. Yeah? You understand that? How he's going west 7 blocks? Cool. Then he goes to the east 5 blocks. He's going east 5 blocks. So that leaves this right here 2 blocks. So he traveled a total of 2 blocks west. You see that, Charlie, how he traveled 2 blocks west total so far?
Yes.
So he traveled 2 blocks west so far. Then he goes up 3 blocks. Then he goes to the west again 3 blocks. So if he already started 2 blocks to the west, and then he went another 3 blocks to the west, how many total blocks did he go to the west? What?
Wait, so like if he's at 2 and he went up 3, so then you just add that together?
No. He was at 2, he went up 3, then he went 3 more blocks to the west. Don't look at the north. Look at this 3 and this 2. You add them together because he's already 2 blocks west, and then you add 3 to get 5 blocks total west.
Yeah, isn't that what I said?
Yeah, but you were bringing in north.
Oh, my bad.
Don't bring in north.
Okay.
Only associate west and east and north and south together.
Oh,
Don't associate west with north or east with south or any of like that.
Oh, okay, for sure. Okay.
All right.
But since from adding the 2 and the 3, that's where you get the 5.
That's where I get the 5. Yeah.
All right, I got you.
All right. Now we know that stuff, so we can draw this again. So we can draw this in a cleaner graph. So he goes up. So in total, he goes. How do I draw this? Let me think. He goes. You can like draw even like that. Like he goes like that. 5, 3, negative 5, 3. So we go negative 5, That's west. And then we go up 3. So that's 5. That's 3. And now she wants us to find the path. The path. So this is easy. You're going to connect your ending to your beginning, and you're going to do it squared. You're going to do the Pythagorean Theorem, which is a squared plus b squared equals c squared. Your a is going to be 5. Your 3 is going to be b. Now you need to find out the hypotenuse. Now, I'm going to be a little teacher right now, and please put your whatever you find for the hypotenuse in the chat, please. All right, we're seeing some good. We're seeing some good. Good job, Mira. Actually, Mira, you're kind of wrong. I'm not going to lie to you. All right, so anyone else got an answer?
She's right. It would have been a Pythagorean triple if the 5 was the hypotenuse. Then
if
the
the
leg
5 was the
been,
hypotenuse, it would have been it. But that's not the correct answer. Oh, Charlie.
Wait, oh, is that some? I think that's something Banana taught us. Wait, it's
All right. Let's go over the Pythagorean theorem. Yes, good job, Gauchik. 5.83. The winner, Gauchik, over here at 5.83. He texted me privately. Good. I'm going to say the answer. So we're going to go over this. If you guys forgot the Pythagorean theorem, a squared plus b squared. So we have this triangle, 3 and 5. And so if we want to find the hypotenuse, and we know this is a right triangle, we can do 3 squared plus 5 squared equals c squared, which is the hypotenuse. So 3 squared plus 5 squared equals 34. So 34 equals c squared. Now we're going to isolate the variable. So you're going to square root c, you're going to square root 34. This square root should cancels out the exponent. So c equals 34 squared, which is basically 5.83. That's how you find the resolute vector. Resolute vector, if you know it's a right angle and you have 2 sides. That's easy way to figure it out. Or if you're smart and you want to go the long way, you can use a ruler to measure it out. That takes too long and it's not as accurate. The theorems are always more accurate. So that's how you find the resolute vector. Good job, Gauchik. Proud of you. All right. And then we have to find the direction magnitude. So let's draw this out again. So we know as it goes something like that. This is like the beginning and this is the end. We know this is 3 and we know this is 5. So we're going to use Sohcahtoa again. And we're going to use Toa since we're looking for this angle. And we're going to use Toa. So Toa is opposite over adjacent. The opposite is 3. The adjacent is 5. So we're in your calculator. You can put second tan. And then you're going to put 3 first since it's the opposite over 5. And that should give you the angle it is at, which is, someone please put in chat what it is. Anyone putting in chat? All right. We're seeing some good numbers. Good job, Alan. Yeah. Okay. Yeah. 30.96 is the angle it is going at. So you would put it is going, your correct answer written out should look like this. You are going 5.83 blocks, not centimeters, blocks, because that's the units we're using. 5.83 blocks at a 30.96 degree. At 30.96 degree. Oh, blah. You don't have to put at. You can just put like that. 39.6 degrees.
Would it be north of west?
North of west. You would put north of west. That's how you would put it. That's how your answer should be written out when she asks for to make sure to include the magnitude and direction in the resonant vector. That's how
Okay,
you'd solve B. All right. Now that's going to be like the hardest thing on the test, really. Vectors. Do we still have time?
We have about 10 minutes, 10 more minutes. Yeah.
Yeah,
10 more
I can
minutes.
take 10 more minutes. And if you want, you can stick around and ask questions. So we're going to go to dimensional analysis.
Wait, Andrew, I have a question real quick.
Yes, Mira?
You know how on the last page, 14, right? You know how where it says scale 1 block equals blank centimeters?
Yeah.
How would you fill that out? Either I'm just overthinking it or I have no idea.
What I would do is I would try to find as
The
close
actual
as I
centimeters?
can.
Okay. Okay.
Which is, it's about like half a centimeter. I
Okay.
put like 0.5 centimeters.
Okay. Thanks.
If it's around 0.5, you just put that.
All right.
Andrew.
Yes, Alan?
I figured out how you did everything else. When you drew the results in, so why'd you put 5 and 3? How'd you do that? Or why'd you do that?
Okay, so you have the same question as Charlie. Okay, so bloop, 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 bloop. So, Alan, don't mute your mic yet. So we have the graph. He goes 7 blocks. Let's just draw this out. He goes 7 blocks east, right?
Right.
So starts right there. So the next direction we're going to do is starting from that line. So we go 7 blocks west. Then he's going to go 5 blocks east. So that's back. We're backtracking. So then he's right here about. Right?
Okay.
So if you do the math, you would just do 7 minus 5, which is 2, yeah?
Right.
Last time I checked, it was 2. So he moved a total of 2 blocks west so far. Do you understand how I got that?
Yeah.
So we know it's 2, so we can just doop, doop, that's 2. Then he goes up north, blah, blah, blah. Then he goes back west 3 blocks. So if he goes back 3 blocks west, and he's already at 2 blocks, what's the coordinate he's going to be at? He's going to be 5 blocks west. I need to explain it better.
Okay. I see.
Do you actually see it? I can explain it better if you want. Or if someone else wants me, I can explain it better.
I get it now.
Does everyone get it? Make sure everyone gets it. Please,
I got it.
Give me a fist of 5 if you get it. All right. Yeah. Okay. We're looking good numbers. All right. Some people left us, but it's because they're not smart enough for this. Joking. Please bleep that out. All right. So we're gonna go having a little fun. This is a little hard. So for like the next 3 minutes, I'm gonna go over the. Do you guys want to go over the dimensional analysis, or do you guys want to go over substitute or isolating the variable?
Isolate the variable.
Isolating the variable. Is everyone okay with that? Cool.
Yeah.
All right. So we'll do like the first 2 questions. All right. So, I got a little whiteboard back here I did it with. All right. So, A equals delta f of f minus v of I over delta t. All right, so now we want to isolate v of f. That's what we want. We want v of f isolated. So, wait, I messed up. This is v of f, yeah. All right, so in order to do this, we can do something very common. First step you're going to do, you're going to get the bottom, the delta t out. So you'll multiply that by delta t. And if you do it to one side, you got to do it to the other. So we got to multiply this by delta t. So this cancels it out. And this makes it delta t times a equals v of f minus v of I. And if we want, so now we want v of f. So in order to get v of f, we got to add v of I to both sides. So if we add v of I, to get v of f isolated, this cancels out, and then you add it here. So your answer should look like this. Should look like delta t times, times a, my a's, plus v of I equals v of f. And that's how you would isolate the variable. Isolating is just like, you just gotta know what to do to the certain side. So we'll do the next one, and I think that'll be it for today. So the next one is asking delta d, blue, 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 blue.
That's the highlight from today. Andrew's blue, 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 blue.
Blue, 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 blue. I took a picture of this earlier. Here we go. So, it's 2 is looking like this. Delta d equals v of I times delta t. I try to make my t's look like, not like addition signs, because I get a little confused by that. It's a little trick for y'all, because they look very similar. Plus 1 over 2 a delta t squared. All right, so we have this, and we want to isolate a. So the first step we're going to do is, feel like this is what I'm going to do. I'm going to go like this and divide everything by v of I times v of t, delta t. So that this cancels each other out. And then we have to put it same thing on here. So v of I and delta t. So now they cancel each other out. Now we're left with this. 1/2 times a times delta t squared.
Wait,
All right.
Andrew, could you just repeat what you did? I kind of lost you for a second.
All right. So the first step, I see this problem, and I want to get to A. And if we're wanting to get to A, I'm going to go left to right, because to me that just seems easier. All right. So if I'm going to left to right, the first things that are in my way is v of I and delta t. They're in my way. So I got to get them out. In order to get them out, I got to divide them, because they're multiplying stuff. So if I do v of I, this divided by delta t, these two things, they cancel each other out. You get that?
Yeah, thank you.
They cancel each other out. So if I do it on this side, I got to do it on this side. Yeah? Comprende?
Yes, thank you.
Spanish class. So they cancel each other out. So we'll just bloop, 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 bloop.
The thing is now, Andrew, you'd be left with, on the right side, you'd be left with 1 plus half a delta t squared over vi delta t.
Huh?
So it wouldn't fully cancel out because you have a sum.
Yeah.
So what it would be is it would be 1 plus this divided by vi delta t squared, or just delta t, because this doesn't cancel. Does that make sense? I think the better option.
What would the better option be?
The better option, try something else. Though I think if you subtract vi delta t from both sides.
If I do what?
Subtract vi delta t from both sides. Instead of dividing it, subtract it from both sides.
Okay, subtract
first.
it?
Yeah, subtract vi delta t first.
All right, so MG is the boss. He's my boss. So we'll subtract vi delta t. Okay, that makes more sense. So if we subtract that, we got to subtract it from both sides. So this cancels each other out. And so you got delta t minus v of I delta times delta t. And so equals 1/2 a delta t squared. And the next thing I would do is, then MG, would I divide by
Yeah.
Would I subtract 1/2?
No.
Or would I do?
Divide. But now because now it's literally attached to the a, and you want to get the a on its own, right? So
Yeah.
because it's multiplying and it's attached to the a, the only way to get rid of it is to divide it. So now you would do the division.
Okay. I don't like fractions. They scare me. All right. So you'll divide that. I'll divide it by 1/2, right?
1/2 delta t squared because you want to get a on its own, right?
So I'll divide by 1/2 delta t squared because I want to get a on my own. So do to that side, this cancels out. Gotta do to this side. 1/2 delta t squared, which equals a. This is your answer. Your
I
answer
think
would
you're
look
missing a
like.
d in there. It would be delta d, I think.
Am
I think you
missing
just
a
forgot
D
to
then?
write.
Yeah,
No,
I'm
like,
missing a D.
yeah,
I'm
you
missing a
just-
D right
yeah.
here.
Yeah, you're good.
So your answer, let me write it all out. A little confusing. Delta D minus V of I times delta T over 1/2 delta T squared equals A. And that's how you would solve it. And then this is like last minute, but I'm just gonna tell y'all to study this because we didn't go over this in class, or at least my class hasn't gone over this. Is the relationship between variables and equations. So give that a good look and study your like what f of g means or what m of 1 means. Study that, and this test shouldn't be that bad. So if y'all don't have any questions, y'all can leave.
Are you gonna post this recording?
Yes, on the YouTube channel. MGU,
Okay.
would you like to?
Yes,
shout out
you guys
the YouTube channel?
should subscribe to it. Andrew pinned the message on the physics Slack. So if you go to Revise Now resources, which is pinned, you'll find the website for Revise Now, and you can subscribe to the YouTube channel. Please do, and then also you can claim CAS hours. So
All right.
do that. Andrew, I mean, I've never seen you teach before because I've never been in a science or math class with you. But honestly, this is great.
Andrew really came in clutch when we all had trouble with
Well, honestly, he helped explain it so well.
with the homework.
All right.
Wow, I mean,
Andrew's blushing down.
you're literally you could literally be a math teacher. I'm not even joking.